Welcome back to our YouTube channel. If this is your first time coming across our video or visiting our channel, don't forget to like, share, and subscribe. In today's video, I'm going to be focusing on factors affecting enzyme activity. And if you haven't watched my previous video on enzymology, that is basic introduction on enzymology, if you haven't watched it, just pause this one right now and go back and watch it. Now, in this video, I'm going to be focusing on various factors that actually affect what activity of an enzyme. And the first one I'm going to start with is actually what the enzyme concentration, right? And when it comes to enzyme concentration, we all know that enzyme is actually the one that brings about the catalytic changes in substrate for it to be converted to what product, right? And initially, in an enzyme catalyzed reaction, whenever there is presence of enzyme and the presence of substrate, the reaction is going to proceed very fast. At times, the concentration of an enzyme tends to affect the activity of the reaction itself, that is the velocity of the reaction itself. So whenever there is increase in the concentration of the enzyme, there is always increase in the enzyme velocity, or let me simply say the velocity of the reaction. Now take for example, focusing on this graph, we have 0 to 10 here that actually serve as enzyme concentration, and we have 0 to 40 here that actually serve as enzyme velocity, or simply say velocity of the reaction. Now if you look at this very well, when the concentration of the enzyme is 0, the same thing happens. There is no velocity of the reaction. There is no velocity, there is no initial velocity at all. That means velocity V naught is equal to what? 0. Then when there is increase up to 10, if you look at this up to this extent, right, there is slight increase in the enzyme concentration. This basically means the velocity of the reaction in an enzyme catalyzed reaction depend on the concentration of the enzyme itself. As the concentration of the enzyme increase, so also the velocity of the reaction will increase at the same time, right? So that basically means the enzyme concentration and velocity of the reaction, they are directly related, right? They have direct relationship. You understand? In such a way that whenever there is increase in enzyme concentration, there will be increase in the velocity of the reaction. So that's just it about the enzyme concentration. Now, the second point I'm going to be focusing on is actually what the substrate concentration. And I said in my previous video that substrate is basically a molecule or substances that an enzyme will act on for it to be converted to product. So in this case, substrate concentration, whenever there is increase in concentration of the substrate, there will be increase in the velocity of the reaction. That is, the enzyme is going to act on the substrate and convert them to products, right, at a very, very fast rate. But one thing that happens is that if we check this enzyme concentration and also in relation to enzyme velocity, we have a straight line graph, which basically means whenever there is always increase in enzyme concentration, there will be increase in enzyme velocity. But if you focus on this guy here, we have straight line first, then at this point it begins to curve, right, to form a stationary line, right? This is actually what a constant line here, right? So in this case, it basically means at this particular point, right, the velocity of the enzyme remain the same, right? That is, initially, when there is increase in substrate concentration, that is, when there is increase in substrate concentration, there is increase in the velocity of the enzyme. But at this point, the velocity begins to remain constant. That basically means whenever we have excess of substrate and then the active site is occupied, the velocity of the reaction will remain the same, because the active site of an enzyme is the particular region where a substrate will bind to for it to convert to product. So once the active site is occupied, then the velocity of the reaction will remain the same. The velocity of the reaction will remain constant. So increase in substrate concentration can increase the velocity of the reaction. But once the active site is already occupied, in that case, the velocity of the reaction will remain constant. And that's basically what you are saying here. That is, and at this point, we have this guy to be V max, that is the maximum velocity of the reaction. And here we are going to have this to be V naught, right? And at this particular point, right, we are going to have 1 over 2 V max, which is half when the initial velocity is equals to half of the maximum velocity. And at this point, that's basically where we have our Michaelis-Menten constant, which is basically Km, right? So Michaelis-Menten constant, I'm going to prove it in my next video, is basically the substrate concentration at which the initial velocity is equals to half maximum velocity. And this is the point, right? That's basically what Michaelis-Menten constant. So one thing about substrate concentration is that increase in substrate concentration will increase velocity of the enzyme, or let me just simply say velocity of the reaction, right? But once the active site is already occupied, right? Due to the increase in what in substrate concentration, then the velocity what will remain what constant, and that's why we're having something that we have like we're having something like this, right? So that's just it about substrate concentration. Now, the next thing that I'm going to talk about here is basically what the temperature. This is basically what temperature, right? And as far as temperature is what is concerned, in chemistry now, when we are talking about chemical kinetics, increase in what in temperature, we basically increase the rate at which what reactant molecule they collide together, right? And that is basically what we enhances the collision of what of the reactant particle. And according to collision theory, it basically says that for a chemical reaction to occur, for any reaction to occur, particles of the reactants must collide effectively, right? So increase in what in temperature, we basically what increase the rate at what these particles actually what collide together. Are you with me now? So in this particular case, or let me just in this particular case, increase in temperature, we basically increase what the rate at which the enzyme molecule and the substrate molecule they collide together. Are you with me now? So whenever there is increase what in the rate at which what the enzyme molecule and the substrate molecule collide together, therefore there is going to be increase what in the enzyme velocity, or let me simply say in the reaction what rate. So increase in what in temperature, we increase what the rate of what of chemical reaction. But if you look at this graph, right, it's kind of different from what from this and also what this. And this is the reason why there is a particular temperature here, right? If you look at this area at this point, right? So at this point, we have it to be optimum temperature, right? What this basically means that we actually understand that the general nature of an enzyme is what is protein. Enzyme are what are protein. And what it means is that whenever there is increase in what in temperature, it can actually what denature the structure of this enzyme. So that basically means that all enzymes they have a specific temperature at which they can function well. That particular temperature is referred to as optimum what temperature. So any decrease or increase above or below the temperature, it will affect the activity of the enzyme. Let me just explain it in this way. We have enzyme, right? Now, at this particular point, that's when the enzyme can perform its function well, right? Now, any decrease, any decrease in the temperature of this or in the optimal temperature will render the enzyme are inactive. That is, the enzyme will not be the rate of reaction will not increase. But above the optimal temperature, what is going to happen to the enzyme is that the tertiary structure of the enzyme is going to be denatured. And in that case, since enzymes are protein and the function of protein is equal to the structure of that protein, if anything happens to the structure of protein, the protein is going to lose its function. So what it means is that increase in temperature above the optimum temperature will actually make the enzyme to denature. It will actually destroy the nature of the enzyme. So that's basically what the effect of temperature. But according to collision theory, for a reaction to occur, the particles, both the molecules of enzyme and substrate must collide together. Then increase in temperature will increase the rate of the collision, but it must not be more than the optimum temperature, because all enzymes they actually have the optimum temperature at which they work best. So that's what it's about temperature. Now let's move to the pH. Now, as far as pH is concerned, all enzymes they actually have their pH at which they work best. And don't forget that as far as pH scale is concerned, right? The pH scale actually ranges from from 0 to 0 to 14, right? Now what happens is that we have 7 here as the neutral. Below this guy here, we have it to be acidic, right? And above this guy here, which is the neutral, we have it to be basic, or you simply say alkaline. Now what happens is that all enzymes generally, whether it is amylase, whether it is carboxylase, whether it is peptidase, all enzymes they have the pH at which they work best. And the pH is basically the optimum pH, right? Just as optimum temperature, we have optimum pH. So optimum pH is the pH at which an enzyme performs its function very well, right? So any alteration in this particular optimum pH, any alteration in this optimum pH will affect the activity of that enzyme. Now let's take for example, now you consume a carbohydrate, right? Amylase generally can actually act in an alkaline medium, right? It can act like the amylase, that enzyme require alkaline medium for it to perform its optimum function. But immediately what the food entered what the stomach, which is highly acidic, what's going to happen? The enzyme will become what? Inactive, right? So that basically means that different enzymes, there are some specific enzymes that they can work best in acidic medium, where there are some specific enzymes that can work best in what? In alkaline medium. So this actually due to the fact that that enzymes are what? Are protein, and the active site of protein is actually designed in such a way that the functional groups that are present there can easily lose what? Hydrogen, or accept what? Hydrogen. For example, let's say we have an enzyme here, right? Like we have an enzyme here, and this enzyme is carrying what? Is carrying a carboxylic acid functional group. That is, the amino acid there actually have what? Carboxylic group as what? As the main catalytic site, right? And let's mind that we have a compound. Like, let me just simply say we have an alcohol, right? Let's say we have an alcohol here, right? We have an alcohol here, right? This is an ethanol. And esterification reaction can actually occur whenever what? Whenever an carboxylic group actually reacts what? With hydroxyl group. It's going to form what? An esters. Now let's imagine that this is basically in the presence of what? Or in acidic medium. That is in a situation whereby this enzyme is present what? In acidic medium. That is in a situation whereby what? This particular active site, this particular functional group can easily lose its what? Its hydrogen. Once this hydrogen is already what? Removed, this may render this enzyme useless. It will become what? Inactive. Because this enzyme is meant to function what? In an alkaline medium, not in what? In acidic medium. So the environment, the nature of what? Of the environment at which an enzyme acts affect what? The activity of what? Of that enzyme in terms of what? Of pH. All enzymes have specific pH at which they work best. That's just it about what? About the pH. Now let's move to the next one. This diagram I'm going to use to explain two things. The first one I'm going to use to explain is actually what? Is actually presence of what? Presence of activator. And at the same time, I'm going to explain presence of what? Of inhibitors. So both activator and inhibitor are molecules that can actually what? That can influence the activity of an enzyme. Now let's move on. The first one that we have here, this particular diagram you are seeing here is basically represent what? Our enzyme, right? This will represent our enzyme. Now this guy here is going to represent what? Activator. This one that we have here is going to represent our substrate. This is going to be our substrate. And then this is basically forward reaction and backward reaction. Now one thing I want you guys to note here is that this enzyme, right, actually have what? Two sites here, right? This is the active site, and this is what? This is another site apart from what? From the active site. This particular site is referred as what? As the allosteric site, while this guy is referred as what? As the active site. Now what happens is that active site is actually what? Is actually the region where substrate growth is going to bind to. This allosteric site is actually a region where any other molecule apart from the substrate can bind to. But the binding of the molecules can actually influence, can change the conformation of this particular active site. So in that case, I'm going to call this guy the active site. I'm going to call this guy what? The allosteric site. This is allosteric site. Don't worry, we are still coming to allosteric enzyme as well. Now, what are activators? Activators are basically what? A positive molecule. I call them a positive molecule because they actually what? Enhance the rate at which what? Enzyme can bind to the substrate. That is, they allow a substrate to bind to the active site effectively. That is basically what? Activator. Then what are inhibitors? Inhibitors are basically what? A molecule that binds to an enzyme and reduce the affinity of that enzyme to its substrate, thereby decreasing the rate of reaction. So what basically happens is that activator basically enhances the rate at which substrate and enzyme collide together, while inhibitor will decrease the rate at which substrate and enzyme collide together. Now let's come back here. We have our enzyme here. We have the allosteric site and we have the active site. This is the activator. Now if you look at this very well, this active site is designed in such a way that it cannot fit in properly to with the substrate, right? It cannot fit in properly with the substrate. Now immediately the activator binds to this site, it's changed this conformation, right? It's changed the conformation of the active site. If you look at this very well, the active site is now open in such a way that the substrate can bind to it. Now immediately the activator binds to it, then the substrate binds to the active site, and as you can see, we have product formation. This is going to be the product. These two guys here, they are what? They are the products. They are the products. Why this is what? This is the what? Activator. In that case, we still have what? Our enzyme. So what happens is that immediately what the activator binds what to this allosteric site is change what the conformation of the active site, enable making the substrate to be able to bind what to the active site for it to be converted to what to product. So a reaction occurs when activator binds what to the allosteric site. In the case of what of inhibitor, this is going to be our inhibitor. This is going to be our inhibitor, and this guy here is going to be the what? The substrate. This is the active site. The active site is where the substrate is going to what? Is going to bind to. Then the allosteric site is where any other molecule, be it activator or inhibitor, can bind to change, to influence what? The conformation of what? Of this active site. Now, looking at this what? Inhibitor. Immediately the inhibitor binds what? To the allosteric site, right? What happens to the active site? It closes. Right? So that's basically what inhibitor do. That's what it usually does. You understand? That's their function. They will basically decrease the rate at which what the active site and substrate can actually what collide together. So in this case, the binding of what of inhibitor to the allosteric site actually closes what the active site. So the active site is what is no longer available for substrate what to bind. And once substrate is what is unable to bind to what to the active site, no reaction is going to what is going to occur. So basically, activator is a positive what molecule or positive what effector. Inhibitor is basically what negative what effector molecule. But both inhibitor and activator can change what the conformation of what of the active site. So that's just it. So these are basically the factors that can affect what the activity of, what, of an enzyme. We have what enzyme concentration, we have the substrate concentration, we have the temperature, and we have what we have the pH. So temperature and pH, they have positive impact and also what negative impact on enzyme. Then the same thing, substrate concentration as your increase in substrate concentration can affect the activity of an enzyme. Then the same thing, enzyme concentration. Enzyme concentration, once the concentration of the enzyme is increasing, there will be increase in what in the what velocity of the reaction. So these are the factors that affect activity of an enzyme. So that's all about this video. Thank you for watching.